Okay, in this video, we're going to go over the 4.1 to 4.3 review. Okay, so we start out by doing just evaluating exponential functions for certain x's on your calculator. So your mode should be in 3, at 3, so that you can have answers that reflect 3 decimal places. Okay, so do that first. Then what this is telling you to do is figure out what 5 to the 1/2 is. You should be getting this. And then what 5 to the pi is. You should be getting this. What 5 to the -3 is. Make sure you use the negative key and not the subtraction key, otherwise you'll get an error. And then the last one is 5 to the e, so make sure you know where e is. And this is what you should get. So this is rounded to 3 decimal places. And I didn't do it in my head. I set the calculator to the mode of 3 to do it. Okay, so then the next problems, 2, 3, 4, and 5, are all based on the uniqueness property. So that means we want to get the same base. So bases that you're going to need are things like 2, 3, 4, 5, and probably 10. You're probably not going to get 6. So just an e being another base that you can use. Okay, so here you have 5 to the x minus 2. Think about 125 in terms of 5. It ends in 5, so you know it's a multiple of 5. So 5 times 5 times 5 is indeed 125. So once you have established the same base, the base is 5, set your exponents equal. X minus 2 equals 3. Add 2 to both sides. You get x equals 5. So plug it in. 5 minus 2 is 3, and 5 to the third equals 5 to the third. That makes sense. Okay, look at the next one. Here's another base, base 3. 27 is 3 times 3 times 3. Remember, this is not 9. It's not 3 times 3. It's 3 taken 3 times. So 3 times 3 times 3. Okay, once I have the same base, set your exponents equal, and add 1 to both sides. Divide by 4, and x is 1 is your variable. Plug it in. So 4 minus 1 is indeed 3. So this is the proper answer. Okay, now you've got to be careful here. I want to get a base of 4 because I know that 64 is 4 to the third power. So here, 1/4 is 4 to the -1. Then take that -1 and raise it to the 2x power. That means do multiplication. This becomes 4 raised to the -2x. That has to equal 4 to the third. You have the same base. Set your exponents equal. Divide by -2. And you get x is -3/2. So if you plug in -3/2 for x, you're going to get +3 over here on the left, and you already have +3 over here, so you know that you're correct. Okay, the last one in this group is base e. So bring up e to the third into the numerator. When you do that, you make the exponent negative. Now you have the unique base. Set 7x equal to -3, and you get x equals -3/7. Okay, multiply 7 times -3/7, and you get a -3, which is what you have over here, so you know that you're correct. Okay, so let's go down, and the next thing we're going to do is talk about expressing equations in exponential form. So if I ask you to do that, that means that I must be giving it to you in log form, and you're going to change the form. Okay, so you want to know the base is 5 for this first one, and the argument is 1/5, and the exponent is -1. Okay, so change it into exponential form. Your base is 5, logs equal exponents, the exponent is -1, and this has to equal your argument. So here it is expressed in exponential form. Let's go on to the next one. 4 is your base. Put your base down. Logs equal exponents. 3 is your exponent. and it has to equal the argument, and the argument is the number or the expression behind the log. So it's 64, and here it is written in exponential form. Okay, so here we go. 5 is the base, 1 over 125 is the argument, and the power is -3. Base is 5, power is -3. It has to equal the argument, which is 1 over 125. Stop there. Here's another one. The base is 8. So you put your 8 down. Logs equal exponents. Here's your exponent, 2/3. And this has to equal the argument, which is the term after the word log. Let's slide down a little bit. Okay, continuing on. Your base is 6. Logs equal exponent. Your exponent is 1. And this has to equal your argument, which is z. Here, your base is 10. So it's unusual to have this 10 here. Usually it would have been just log 3 equals 2t. But they gave it to you, so that was nice. If it wasn't there, I would still expect that you would know that was base 10. So here's base 10. Logs equal exponents. Here's your exponent, 2t, and that has to equal the argument, which is the 3. So that's converting from log form to exponential form. Okay, you want to be able to go the other way as well. So these are exponential forms, and we're going to put it into log form. So the first thing you want to do is write down the word log. Now here's your base, this log base 4 of the argument equals the exponent. Logs equal exponents. Log base 7 of the argument equals the exponent. Logs equal exponents. Log base 3 of the argument equals the exponent, because logs equal exponents. Okay, so look, this is log base 10. So we're just going to write down log. Here's the argument, 0.1, and logs equal exponents, all set. Okay, so be able to convert both ways, either from exponential to log or from log to exponential. Have a strategy and be able to implement it consistently. Okay, this says evaluate the logarithm without using a calculator. So what you're going to do is you're going to set each of these terms equal to x. Then you're going to solve for x. So that means just change the form. These are all logs. We're going to change them all to exponentials. So your base is 3. 3 logs equal exponents to the x equals the argument. So therefore, since you have unique base, x equals 7, and you're done. Okay, B. 4 to the x equals 64. Remember, your job is to solve for x this time, so I can't leave it like that. Change 64 to 4 raised to the 3rd power. Now you have the uniqueness property. The bases are the same. Set your x equal to 3, and you are done. Okay, start converting. Logs equal exponents. So 5 to the x equals 125. We're not done because we have to solve for the x. Change your 125 to 5 base 3. Excuse me, 5 power 3. Set your powers equal because you have unique base, and you're going to get x equals 3. Here is 2 to the x equals 32. 32 is 2 to the 5th. Once you have the same base, set your base equal to x, and you're done. Okay, 8 to the x equals 8 to the 17th. X is going to equal 17 because the bases are both the same. 6 to the x equals 1. Okay, so this can be confusing, but I want you to remember that any number to the 0 power is 1, and you need the base to be 6. So you're going to choose 6 to the 0. X is going to equal 0, and you are done. Okay, here you're going to change your mode to 4. So once your mode is 4, You're just going to type in log 2.3 and you're going to get 0.3617. Log of 2 times the square root of 3, and you should get 0.5396. Now this is natural log instead. Natural log of 7.2, and you should be getting 1.9741. Okay, let's keep going since we're on a roll. Okay, so I had you do this, well, I told you you could do this two ways. Pick the way you like. It's all based on the fact that you cannot take the log of a number that's 0 or negative. Therefore, that forces x minus 4 to be greater than 0. Solve for x. X has to be greater than 4. If x is greater than 4, then my domain starts at 4, but doesn't include it, because it has to be greater than 4, and continues on to infinity. Notice I have parens both places. If you like the idea of plotting things, here is a transformed function. This is the parent function y equals x, and is pushed down 4 units. So find your y-intercept, find your x-intercept by setting the y to 0. That's going to be 4. So all the yellow highlight here, or orange highlight, I guess, are values that you cannot have because these y's are negative. So what x's give me y's that are positive? Well, I start at 4. I can't equal 4. That's why I have the paren, and I go to infinity. So whether I do it by plotting or by figuring out the inequality, in either way, I will get 4 to infinity as being my domain. Okay, let's do this next one. So if you want to do it by using algebra, you're going to take 2x plus 5, set it greater than 0, and then solve for the x that makes that happen. X is going to be greater than negative 5/2. Start your domain at negative 5/2, non-inclusive, and go all the way to infinity. If you plot it, again, it's a transformed parent function of y equals x. Here is your x-intercept, or your root of your function. That's where y is 0. So you can't include this, and you can't include any of the x's down here, because what happens? They generate negative y's. So what you want to do is start at negative 5/2, but don't include it, so this should be an open circle, and then go all the way to infinity. So no matter which way you do it, you will get the exact same domain. Okay, last topic is finding the inverse of the exponential function. Remember how to find inverse. First step, take it out of function notation. This is already out of function notation. So switch, so I'm just writing it down again, then I'm going to switch my x and my y. Solve for the new y by writing it in log form. Here's your base, here's your exponent, here's your argument. Log base 6 of the argument x equals the exponent. This is now your inverse function. Okay, so you should be able to do that. Let's do one more. So again, I want you to find the inverse of this. It's already out of function notation, so just switch your x's and your y's, and now you're going to write it in exponential, it's written in exponential form. You are going to write it in log form. So your base is 8, log base 8, the argument is x, logs equal exponents, it's y minus 7. Now, you want y by itself, so you're going to have to add 7 to both sides. That gives you your new y, and then switch it so that it's an inverse function notation equals log base 8 of x plus 7. Okay, those answers should match what my key is, and they should definitely match what you have. If you're having difficulty with this, please come and see me. Okay, do not leave things blank on the review. Do not just copy my answers on the review. That will do you absolutely no good. The homework grade is not going to be what you are going for. You want to make sure that you understand every single one of these problems, and that you could start it on your own and you can complete it on your own, and you get the same answers that I'm getting. Okay, come see me if I can be of help.